Today we're going to graph radical or square root functions and inequalities. And we're going to first take a look at our parent function of y equals the square root of x. In order to graph this, we're going to pick some points, and the points we'll pick are perfect squares for x and then find their square roots, which are y. So I'm going to take and start with 0 since I can't use any negatives. Square root of a negative number doesn't exist, it's imaginary. Then I'm going to go to 1, 4, and 9. And that'll be our basic pattern throughout. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and the square root of 9 is 3. Now I graph those points. Here's 0, 0, 1, 1, 4, 2, 9, 3. And we get some curve shape that looks like this. Domain of this is x is greater than or equal to 0 because it's all x values to the right of 0. And the range for this is all y's that are greater than or equal to 0 because it starts at 0 and moves up forever. Let's quickly review our HK properties. We know any function can be written in y equals a times f of x minus h over b plus k, where h and k are the horizontal h is the horizontal translation, k is the vertical translation, a is your y multiplier, and b is your x multiplier, noting that we need a coefficient of 1 in front of the x and the b has to be in the denominator. Let's go ahead and look at a number of these different properties within our radical graphs. So in this case, if we want to write this in the proper form, that's the square root of x minus a negative 1 because we have to have x minus h, and then plus 4, so we know h is negative 1, k is 4, everything else is equal to 1, so I know this moves it back, this moves it up. Parent function is root of x. Pattern. Remember, the only thing that changes the pattern is the a and the b values. So 0, 0, 1, 1, 4, 2, 9, 3. We're going to do all that from our translated origin, which is back 1 and up 1, 2, 3, 4. So I'm going to put a little dotted line right here. And that's where we're going to start graphing this pattern. So here's 0, 0, 1, 1, 4 over, and 2 up, and 9 over, and 3 up, and I graph. So we could pick a point to check, which is what I always recommend. This is a point 3, 6 apparently. Plug 3 into the x value. That's 3 plus 1, which is 4. Square root of 4 is 2, plus 4 is 6. So 3, 6 checks, and I've graphed it correctly. My domain, I look, x goes from here over. So where is here? That's domain x is greater than or equal to negative 1. The range from this y value up, so that's y greater than or equal to 4. Likewise, same parent function, root x, same pattern because there's no h and k in this case. We have x and y. We've got 0, 0, 1, 1, 4, 2, 9, 3 again. Notice, very similar to the last problem, rewrite x minus a minus 5. This goes down 1 though, so I'm going back 5, down 1. And you'll notice this time we have an inequality. We'll deal with that in a minute. So if I go back 5, down 1, put my little crosshairs there, we're going to graph the pattern from that. So here's 0, 0, 1, 1, 4, 2, 9, 3. I draw this graph, and then what I have to do is I'm going to have to check a sample point because we've got a shading going on. Once again, I'm going to check 0, 0. So I'll see if 0 is less than or equal to square root of 0 plus 5 minus 1. This is some number bigger than 1. I'm going to say it's 2 point something minus 1, which still equals some number greater than 1. I don't know what it is, but is that greater than or equal to 0? You bet. So 0, 0 exists in the shaded region. Have to be a little careful on our shading here because we know we can't go to the left of 0 because in our domain we'd get a negative number when we plug like a -6 in. So I shade straight down from here forever, but I don't go past or to the left of that starting point. So we use our same pattern of 0, 0, 1, 1, 4, 2, 9, 3. But in this case, since we have a y multiplier of -3, we multiply -3 to each of these y values. So I get 0, -3, -6, -9. I'm going to take and move over 2, up 0, put my little crosshair there, and graph the points 0, 0, over 1, down 3, over 4, down 6, and over 9, down 9. Go ahead and graph that. Whoops. Connect the dots would be better. This looks like the point 6, -6. We'll check that real quick. Put in a 6 here. Get 6 minus 2, which is 4. Take the square root of 4. We get 2. 2 times -3 is -6, and sure enough it checks. As far as domain and range, x's move to the right from 2, so my domain is x is greater than or equal to 2. My range, the y is moved down from 0, so y is less than or equal to 0. So in this problem, once again, we have an inequality, except we have an a, h, and k, h equaling 2, k equaling -5, a value of 1/2. Parent function still the same. Pattern gets multiplied by 1/2. 0, 0, 1, 1, 4, 2, 9, 3. Multiply by 1/2, get 1/2, 1, and 1.5. Go ahead and plot that point of 2 over, 5 down, and then graph our pattern from that. Here's your 0, 0, your 1 and 1/2, your 4 over and 1 up, and then your 9 over and 1.5 up. Very slightly rising. Now, the shading is going to be a little bit different because we can't really test a point 0 because 0 is not in the domain. We notice the domain is greater than 2, so I've got to check some other point. I'm going to check the point 3, 0 just for the heck of it. So when I do that, I notice that 0 has got to be greater than or equal to 1/2. 3 minus 2 minus 5. Well, then we know at this point we get 1/2 square root of 1 minus 5, and we know that's 1/2 minus 5, and is 0 greater than 1/2 minus 5? Sure is. So since I tested this point and it works, we shade up. Notice again, we don't go to the left of the starting point. Now in this problem we have a b value and it's not written in the correct form because I have a plus here. So I'm going to rewrite it. Y equals square root of x minus a negative 7 over 2 minus 3. I have an h value of negative 7, k value of negative 3, and a b value of 2. Same old parent function, and in this case we have an x, we have a y, but now our multiplier goes to the b term. So here's our 0, 0, 1, 1, 4, 2, 9, 3. Multiplying these guys by a 2 gives me a 0, 2, 8, and 18. We're going to back up 7 now and go down 3. Start everything from that point and move forward with the pattern from there. So here's our 0, 0. I'm going to move over 2 this time and up 1. Going to move over 8 from there and up 2. And then 18 over and up 4. Puts me over here. Looks something like this, where my domain is x is greater than or equal to negative 7, and my range is y is greater than or equal to negative 3. Now in this case, you'll notice that there is a multiplier inside. We have a coefficient of 1 out in front of this x, which is good, but my b value is not on the bottom, so I'm going to redo that. Y equals x minus 2, and that has to be over. How do you multiply by 3 but divide? Same as dividing by a third. So that's my b value. H is 2, b is 1/3. Parent function is still radical x. Pattern doesn't change a whole lot. We're multiplying our x's by a third. 0, 0, 1, 1, 4, 2, 9, 3. Multiplying by a third, we get 0, 1/3, 4/3, and 3. So we graph that again, all from the point 2, 0. Here's 0, 0. I move over a third and up 1. Move over 4/3 and up 2. And then move over 3 and up 3. So this compresses in this time. Domain again is x is greater than or equal to 2. Range is y is greater than or equal to 0. Getting close to being done. A couple more examples. In this case, we notice there's a negative on the outside that acts like an a value. Coefficient of 2 in front of the x, that's got to change, so we're going to have to factor and move from there. So let's go ahead and do that. Y equals negative. Factor out the 2, so now we have a coefficient of 1 on my x plus 7. Notice this multiplication of 2 has to be down in the denominator, much like the last problem. So I have negative x plus 3 over a half plus 7. Got h value of negative 3, k value 7, a value negative 1, b value of a half. So I've got a lot to do with the pattern this time. Zero, 0, 1, 1, 4, 2, 9, 3. To all the y's, I'm going to multiply a -1, 0, -1, -2, -3. To all the y values, I'm going to multiply, or sorry, to the x values, I'm going to multiply a half. So it's 0, a half, 2, and 4.5. So I move over now 3 to the left, and I go up 7 and move in my pattern movements from that point. Here's 0, 0. I'm going to move over a half now and down 1. I'll move over 2 and down 2, and then I'll move over 4.5 and down 3. And there's my graph. Domain, x in this case, greater than or equal to -3, y less than or equal to, in this case, 7. Finally, we're going to take and write the equation of some of these graphs based on these parent functions of root x. So I notice right off the bat I have -6, -4 having an HK. I tend to ignore the b when I'm writing equations and just always make that 1 and find my a value. So currently I have y equals a root x plus 6 minus 4. I need to find a, which means I'm going to need another point. So I'll use this point right here of -2, -2, and plug that in for x and y. Here's -2 equals a times the root of -2 plus 6 minus 4. Solve for a by bringing the 4 over. This gives me a 2 is equal to a times the square root of 4, which is also 2. Divide by 2, and a is equal to 1. So my equation, y equals root x plus 6 minus 4. Done. Last example. Identify your h and k first. We're at 1 and 8. So I have y equals a root x minus 1 plus 8. Pick another point and plug that in. This is the point 5 and 2. I'll plug that in. So I have 2 equals a times 5 minus 1 plus 8. You notice this gives me a square root of 4 plus 8. Bring the 8 over, that's a -6, equals 2a, and a equals -3. Therefore y equals -3 root x minus 1 plus 8. That'll get it done. Make sure you fill out your summary and do your Connect Ed, and we'll talk tomorrow.